Before we go on to the slides that you have in your PowerPoint slides, I want to do an extra problem. This problem actually deals with Twizzlers. Oh, I like Twizzlers, I really do. And I don't like the black ones, I like the red ones though. Chocolate ones are good too. And it deals with Twizzlers, and it deals with the concept of a gross. So it says, how many Twizzlers do you have if you have 1.5 gross? And again, you may not know this, and I wouldn't put this to you on a test, but 1 gross is equal to how many? 1 gross is equal to 144 or 2 dozen items. Okay, so here if we say, all right, I've got 1.5 gross, does this make sense that I have basically 144 times 1.5? Does that make sense? Well, I'm going to show you to work this problem using the factor label method, and you have to. I know you can just kind of think through these, but you can't always think through chemistry problems. What we're going to do is we're going to convert gross to number of Twizzlers. Oops. And so the number we're going to start with is that 1.5 gross over 1. Okay. And then I'm going to use these, and we've done this before, I'm going to use this equivalency statement up here. Okay. I'm going to put gross on the bottom and units of Twizzlers on the top. So my next term goes like this. 1 gross on the bottom. Oops, goodness gracious. 1 gross on the bottom and 144 Twizzlers on top. Okay, now in our calculators we tap that in and we get 216 is what your calculator will say. 216 is what your calculator says. Now units would be Twizzlers. And then one more thing, how we need to round this. Well, if I'm going with uncertainty here, I need to round according to 2 sig figs, so I'm going to have to truncate that thing. So my answer is going to be 220 Twizzlers. I'll just put Twiz for Twizzlers. Okay, does that work for you? So I have another, let's see how this works. Yep, I got one more problem down here. It goes like this, and it's kind of got a little bit written over, but it says, how many gross of Twizzlers do you have if you have 72 Twizzlers? So now, in this case, how many gross? So we're going to gross, and we are coming from, gross is like a pocket, it's like a dozen, okay? Gross is honestly like a mole. So we're going to gross from the number, these number of Twizzlers, 72 Twizzlers. I'll just put Twiz for Twizzlers. So in this case, our first term is going to be what we want to convert, 72 Twizzlers over 1. Put Twiz for Twizzlers. And then I'm going to go back up here to this, what I have, this equivalency statement. And in this case, I want Twizzlers or items to cancel. So I'm going to put those in the bottom. So I'm going to put 144 Twizzlers. And I want to be left with gross, which is great, in 1 gross. Okay, so Twizzlers cancel. I'm left with units of gross, which is great. And then if you divide this out, you put this in your calculator, you're going to see that it's going to give you actually 0.5. That's what your calculator is going to say. And units would be what? Gross. So again, I'm going to hold you accountable to how do we need to round this. Well, I know it seems like this might be an exact counted number. We're going to say there's uncertainty in my 72. And there's no uncertainty brought because by definition, 1 gross is 2 dozen or 144. So I need to give myself 2 sig figs. So what does that look like? So there's 1 sig fig, and I need to give myself another sig fig there. So what your answer is going to be is 0.50 gross. And a lot of times with working problems, you're like, does that make sense? You're like, well, if I have 72, 72 is a half of 144. I did that on purpose. So yeah, that makes sense. Okay, so let's scale it up and kind of do it with regard to what a chemistry problem might look like. So again, in chemistry, we count amount in moles. because things in chemistry are very small, whether they're electrons or protons or atoms or molecules. So we're going to use this concept of a mole. So 1 mole, okay, is equal to 6.022 times 10 to the 23rd. And again, that there is uncertainty in that number. Okay, so we can, down here you see that we've taken this equivalency statement and made two ratios. Now, sometimes I will call this ratio A and ratio B. And it's like, which one are we going to use? Well, it depends on what we want to cancel and what we want to be left with. Oops, I should have. So notice up here we have moles and atoms, and down here, over here, we have moles in the bottom and atoms in the top. So let's see what a problem would look like. So the first one is how many moles. Okay, so one looks like this. Sometimes I kind of take my time, how many moles, so I'm going to put moles over here on the right, question mark moles, okay, is 1 trillion hydrogen atoms. So 1 trillion. So what is that? 1 times 10 to the 12th? That's what I'm liking, okay? 1 trillion hydrogen atoms. Well, we can use Avogadro's number to get there. Let's just go ahead and take a quick look at number 2. The second one is how many atoms, question mark atoms, are there in 0.555 moles of atoms. I don't care which element it is, of any atoms. Now notice that for both of these you see something in brackets. Okay, that something in brackets actually doesn't necessarily need to be there. So a lot of times when I do a problem like 1, it will say how many moles is 1 trillion hydrogen atoms. For 2, it will read how many atoms is 0.555 moles. Okay, so, all right, so let's see what we got. For the first one, our first term is going to be, and I probably would go ahead and put a number, 1 times 10 to the 12th hydrogen atoms, and I'm thinking in my solution, I say that that's exact. I can't remember, but I think so, which is kind of weird. Usually there will be uncertainty there, but if we have exactly 1 trillion hydrogen atoms, I would put that over 1, and now do you see I want hydrogen atoms to cancel, and I want to be left with moles in this case, so what does that look like? 1 mole is 6.022 times 10 to the 23rd atoms. Awesome, and we're done. Okay. So you're going to need to remember how to do scientific notation. And I don't have the unrounded value handy, but do you see why this answer, if I went with exact here, no uncertainty brought, there is uncertainty brought by in the coefficient of Avogadro's number. So I have to round according to 4 sig figs. Hope that works for you. Let's go to the second problem. The second problem, we were going from what? Moles to counted atoms. So the first term, and I usually put it over 1, is going to be the thing we want to kind of convert from moles to atoms. So do you see here where I'm going to go ahead and put units of moles in the bottom, and I'll put units of atoms up here. I usually focus on the units and then I write the number, and I know there is 1 mole is equal to 6.022 times 10 to the 23rd atoms. It looks like this. Units of moles cancel. We're left with units of atoms. Now in this one, I'm hoping you're good with this. Is there uncertainty brought here? Yes. There's 3 sig figs. Is there uncertainty brought here? Yes. I got 4. So we need to round according to what? 3 sig figs. So is this what you get? I got 3.34 as the coefficient times 10 raised to the 23rd atoms. And I hope that kind of makes sense, because 0.555 is about a half. And about a half of 6.022 is 3.34 times 10 to the 23rd.